Again, everyone. Hopefully a slightly less sad speech this time, a slightly less emotional topic, unless you are particularly passionate about counterfeiting, in which case this is just as emotional. Okay, so I'm going to start. So another thing that the pandemic has shone a light on are global supply chains. And it's shone a light on the extent to which our supply chains are international. And this has called into question the sustainability of having so many different parts of a product manufactured and assembled in so many different countries and so far from the points of sale. Now, another area that's been less spoken about during the pandemic, but where the global nature of supply chains has also had a negative impact, is counterfeiting. Now, this is because the more parts there are in a supply chain, the more exposed the product is to counterfeiting, and the more opportunity that counterfeiters have to introduce counterfeit components into products and to introduce counterfeit products into the global supply chain. According to the OECD, the Organization for Economic Cooperation and Development, the risk of purchasing a counterfeit product in the EU or in the United States is about 1 in 20, and that number is growing every year. So this is a pressing problem. And in fact, last year, the OECD predicted that by the end of 2020, about $2 trillion worth of counterfeit goods would probably be sold worldwide. Now, to put that in perspective, that's roughly 2% of everything that's sold worldwide. And I'm sure I don't need to convince you of the risks of counterfeit medicines that might not contain the active ingredient that they're supposed to, or toys that have been painted with lead paint, or car brake pads that have been built with inferior quality materials. But this problem has been so prolific largely because of the advancements that we've seen in technology. And these advancements have made it easier and cheaper for counterfeiters to duplicate products, to reproduce their essential characteristics, and most importantly, to replicate their security features. However, the technological advancements have also brought about advancements in anti-counterfeiting, which we can celebrate if we want our car brake pads to work properly. And in fact, lots of anti-counterfeiting elements are actually present on products, perhaps without us even realizing, either because we've gotten so used to seeing them that we take them for granted, or because they are invisible and have been incorporated into the product. Now, these elements range from the most simple, basic security measures, such as labels, to highly complex tools, such as implanting DNA codes into products to allow for them to be uniquely identified. So what I like to do now is to discuss a few of the different technologies that exist, so that you can rest assured that you are buying the genuine articles when you do buy expensive and necessary and urgent products. So I'll start with the more simple. I'll start with labels. Now, we're used to seeing labels on all our products, and often the absence of a label will trigger a warning to us that the product that we're about to buy has possibly been tampered with. The most simple labels include the unique product information, and this could be in the form of a barcode, which needs to be scanned to confirm that the product is authentic. But there are also more advanced types of labels. For example, I don't know if you have come across these labels where when you try and take them off a product, they leave a horrible stickiness, or you can't get all the paper completely off, and it's just annoying because your product is just left with all this sticky paper on it. Well, I have, and I found it very annoying. But that's actually a feature. The label is actually supposed to do that, it turns out, because that is probably one of the ultra-destructible labels. Now, these ultra-destructible labels have been designed so that if anyone tries to remove them, they will disintegrate or make it impossible for them to be removed fully. So any tampering is made completely obvious. You can also incorporate other more advanced technologies into labels. So for example, there is such thing as radio frequency ID technology, or RFID technology, which is usually come in the form of a chip containing an antenna and a circuit. And these RFID tags, can transmit data via radio waves. So any label that has an RFID tag incorporated into it can be scanned remotely with a special device, and the information about the product will be readable. And in some cases, these RFID tags also have a sensor, which, when incorporated into a label or placed on a product, will enable the product to be monitored and tracked throughout the supply chain. And labels that have this kind of technology incorporated into them are called smart labels. Now, another technique or technology that can be used on labels are holograms, which I'm sure everyone has heard of holograms. They're almost ubiquitous on CDs. I'm trying to think of all the different products I've seen them on. They're on lots of different labels, and they're so ubiquitous that generally when you see a hologram, you'll know that's a universal signal that that product is authentic. And the good thing about holograms is that if they're photocopied, then it will be clear that what you're seeing is not the authentic product, because the hologram cannot be seen fully. And even if the counterfeiters have access to advanced holographic equipment, then they often won't have access to the original hologram. And so any differences between the original hologram and the counterfeit one will trigger an indication that the product we're looking at is counterfeit. Of course, you need access to the original hologram to prove that, but we rely on our customs officials. So another technology that can be used on labels or on paper valuables in general, and when I say paper valuables, I mean banknotes, checks, certificates, passports, ID cards, etc. Another technology is microtexts. Now, microtexts are texts, as the name would suggest, or numbers or lines of code that are tiny. They're under 0.2 millimeters in height, and they are so tiny that when they're printed on a label or on a product, they may appear just as a line or a nice design feature to the naked human eye, but when they're read with a specific device, then it becomes clear that what they are in fact is code or an identifying feature, and allowing the product to be authenticated. However, if a counterfeiter attempts to photocopy or make a copy of the banknote, let's say, then all they will do is just reproduce a line that cannot be read by a specific machine, and therefore notifying that the banknote is a counterfeit one. So staying with paper products, another way of protecting paper products against counterfeiting is ink. And there are a whole range of different security inks out there to do this job. There are UV sensitive inks, there are infrared inks, and these can only be detected by a special reader. And another slightly more interesting ink is magnetic ink, which is widely used in magnetic ink character recognition technology. Now, if that means nothing to you, as it did to me a few days ago, I'm sure that you have actually all seen these in use before, because magnetic ink character recognition technology is a technology that is used to print the numbers that run along the bottom of checks. Now, even if you haven't used a check in the past decade, you will know that you'll probably remember that every check will have specific and quite stylized numbering along the bottom. Now, these numbers are actually printed with magnetic ink. And that means that even if the number on the check has been otherwise obscured with felt tip, I don't know, with something to try and scrub out the number, then the number will still be able to be read and authenticated by a machine because of the magnetic ink. Now, another type of ink is optically variable inks. Now, these inks show up in different colors when they're viewed from different angles. For example, if you think about the numbers on banknotes, like the 50, not that I've seen a 50 on a Euro 50 banknote for a while, unfortunately, but for example, the 50 on banknotes, these numbers will show up, sometimes they show up in, I think, goldy green, and viewed from a different angle, it will be more reddy purpley. Now, copiers cannot replicate that color change, which makes it clear that any copy is a counterfeit. And this is also one of the best anti-counterfeiting technologies or inks to use, because it is so difficult to reproduce, and it is also very expensive. And that is why you'll only see this type of ink used in very small areas. Now, for drinks and liquids, there are anti-refill caps. These are usually devices that consist of many small balls that are placed inside the lid of a bottle, and they allow liquid to be poured into the bottle, rather poured out of the bottle. They allow liquid to be poured out of the bottle, but don't allow liquid to be poured in. And therefore, they prevent the bottle being refilled with cheap imitation liquor and then being resold. In fact, this is a much more prolific problem than you might think. It seems that up to 1/4 of spirits and wines sold worldwide are actually counterfeit. So moving on to garments and clothing, or a technique that can be used on a variety of different materials, we have now slightly more advanced chemical encoding and tracers. Now, these chemical tracers work by attaching tiny chemical particles to raw materials or finished products. And these chemical particles have unique properties. For example, they might have a colored reaction to light, or they might also be magnetic. And when these chemical particles are detected by special reading devices, then they will prove the authenticity or the origin or the quality of a product. They can be attached to almost anything, and they could be applied in a pattern to show the origin of the product, or to certain components of the product to show the quality of it. For example, if a garment is supposed to be 40% cotton, then a chemical tracer could be added to the cotton yarn at the beginning of the production process, and then later, maybe even years later, even after the product or the garment has been bought and used and resold perhaps, then a special reader will be able to measure the chemical tracer in the garment to verify that there is in fact 40% cotton content in it. And the final anti-counterfeiting technology, the most complex, to go back to the DNA codes that I mentioned at the beginning, DNA codes can be specifically generated and implanted into products or materials. and they can then be read again with special devices to verify the authenticity of a product. So as you can see, or as you can hear, there are lots of different innovative solutions to counterfeiting that have come about mostly in the past 20, 25 years, thanks to advancements in technology. But of course, as technology advances and gets cheaper, then counterfeiters will also learn to replicate the same methods. It might take them 2 to 3 years maybe. And in fact, I read in an article that sometimes the idea is just to stay 2 or 3 years ahead of counterfeiters by implementing this advanced technology. And then in the 2 to 3 years that it takes counterfeiters to catch up, to develop more technology, and that way stay ahead of them and keep the cycle going of always being a step ahead of counterfeiters. And all I can say to conclude is, I hope they do. I hope they still manage to stay. When I say they, I mean manufacturers of products. I hope they manage to stay steps ahead and always ahead of counterfeiters, because I, for one, do not like the idea of boarding a plane that is made up of 2% counterfeited parts. Thank you.